Hi guys, so we're going to take a look at question 2 from paper 2 of the 2015 exam. Okay, so we have a survey of 100 shoppers. Okay, let's mark what's important. Randomly selected from a large number of Saturday supermarket shoppers. Showed that the mean shopping spend was 90.45. The mean 90.45. And the standard deviation was 20.73. Okay, so what is it giving us? So a survey of 100 shoppers. Okay, so our sample size is 100. The mean shopping spend was 90.45. Okay, the sample mean, the mean from the sample, x bar, is 90.45, and the standard deviation, our sigma, is 20.73. So we want to find a 95% confidence interval for the mean amount spent in a supermarket. So we have the sample mean, we're trying to find the true mean. Okay, so we have a formula for this. So we know that the true mean, mu, is less than the sample mean minus 1.96 times the standard deviation over the square root of n, the size of the sample. And it's less than, with 95% confidence, x bar plus 1.96, the standard deviation over the square root of the sample. Okay, so we can actually just plug this in. We've written down what these things are. So 90.45 minus 1.96 times the standard deviation, 20.73, all over the square root of 100, less than mu, less than 90.45 plus this standard error of 1.96 times the standard deviation. Oops. Over the square root of 100. Alright, so let's just plug that into our calculator. 90.45 minus 1.96 by 2.073, or 20.73 over 10. And that's 86.39. 86.39. We're going to do 2 decimal places because we're working in euros and cents. Less than mu, less than 90.45 plus 1.96 by 20.73 over 10. And that's 94.51. 51. And that's our confidence interval. Yeah, you could also write it like so, a bracket, 86.39, 94.51. But this form is usually fine. A supermarket has claimed that the mean amount spent by shoppers on a Saturday is €94. Based on the survey, test the supermarket's claim using a 5% level of significance. Clearly state your null hypothesis, your alternative hypothesis, and your conclusion. Okay, so a supermarket has claimed that the mean amount is 94. Okay. Based on the survey, test the supermarket's claim using a 5% level of significance. Clearly state your null hypothesis, your alternative hypothesis, and your conclusion. All right, so let's just state our null hypothesis. So, the null hypothesis is always that the claim is true. Claim is true. 94 The null hypothesis is that the true mean is 94. And the alternative hypothesis is that the claim is false. Mu does not equal 94. So a 5% level of significance corresponds to a 95% confidence interval, and we've already done a 95% confidence interval. So if you hadn't, you would do a 95% confidence interval. Using the sample mean. Let's just call that x bar, and see if the mu from the hypothesis is within the confidence interval. So a 5% level of significance means that if you're going to disprove, so let's just write this in, 5% level of significance means you have to be 95% sure or more that H naught, the hypothesis, is false to reject it. So you've got to be very sure. Okay. And what you do in a confidence interval is say we are 95% confident or 95% sure that the true mean is within this interval. Okay? And so 94 actually let's just write it like this. 86.39 is, so 94 is within 86.39 is between 86.39 and 94.51. So we fail to reject. We couldn't reject it because we were less than 95% sure that H naught is false. So we fail to reject. And now it's important to say that we don't accept it. We're not saying, all right, we're not saying we've proved it or we accept that it's 94. We're just saying we couldn't disprove it. I mean, 94 is still quite a bit away from, 94 is just within it. So, we don't know if it's 94, but we don't have enough evidence to say it's not. So so that's how you want to phrase it. So we fail to reject the null hypothesis. So that's our conclusion. Now on to part C. Find the p-value, the dreaded p-value, of the test you performed in part B above and explain what this value represents. Explain value represents in the context of the question. All right, okay. So people really don't like the p-value, but it's actually really not that complex. Okay, so what is p-value? The p-value is sort of like the measure of how unlikely the test results were. So the sample results were. Sample results were, assuming that the null hypothesis is true. Assuming that the null hypothesis is true. But it's actually a little bit more complex than that, and your teachers might actually not go into this this level of detail, and the marking scheme doesn't even go into this level of detail, interestingly enough. So it's actually more like, what are the odds of getting a result as weird or as unlikely or less likely? That's an important caveat. So if we have like a normal distribution, apologize for my horrific normal distribution. Okay, so in this case, let's say our mean is 94. Okay, we're assuming that that's the mean. And our result was like 90.45. So let's say it's over here. Let's say it's over here. Okay, 90.45. So the p-value would be, it wouldn't just be the probability of 90.45, because since it's a continuous thing, the probability is basically 0. But it's actually the probability of 90.45 or weirder or less likely a result. So that includes all these. But it also includes all these. So anything red would be less likely than the results. So what's the probability, less likely or equally likely, what's the probability that, given our assumption that the mean is 94, what's the probability that something less likely than our sample results occurs? Alright, so using that knowledge, well, we know that the sample mean is normally distributed. Sample mean is normally distributed. So it actually does look something like the drawing. Normally distributed. And we know the mean, 94, and we know the standard deviation, 20.73, with mean 94 and standard deviation of 20.73. Okay, and so we're going to try and get the z-score for this. So we know the formula for the z-score. Z equals your sample mean minus the true mean all over the standard deviation over the square root of the size of the sample. So that's just n, square root of n. Alright, so we're just going to fill that in for our case. So we've got 90.45 minus 94 all over 20.73 over 10. Alright, so if we put that into a calculator, we get minus 3.55 over 2.073, which is about minus 1.71. Minus 1.71. Okay, And then if we go to our log tables, the page with all the z-score results. So what's the probability? So we're looking for the probability that z is less than minus 1.71, so like a higher negative number, or z is greater than 1.71. So z is less than minus 1.71, so that's this area. That's this area here. And z is greater than 1.71 is this area. So we've got to find both areas. And we know that the normal distribution is symmetric. Okay? Which means the size of those two areas are the same. So we can just calculate the probability that z is greater than 1.71. And then just multiply it by 2. Okay. And so what do the log tables tell us? Well, the log tables actually give us the probability that z is less than a number. Okay, but we can use this since we know that 1 minus this is what we're looking for, the probability of z greater than 1.71. Okay, so then we can just plug this in, and our answer will be 2 by 1 minus the probability of z less than 1.71. And then we just go to 1.71 in the log tables, 1.71, and it gives us 0.9564. So we get 2 by 1 minus 0.9564. Okay? And that'll be 2 by 0.0436. 2 by, I think, 1 minus 0.9564. Yeah, by 2. And that is just 0.0872. Okay? But the p-value, yeah, so this is the p-value, 0.0872. Okay? Equals our p-value. And so what the 5% level of significance means was if you had a p-value, so because our p-value was greater than 0.05, we rejected, we didn't reject the null hypothesis. So if the p-value was like 0.02, then we would have rejected the null hypothesis. Okay, so what does this mean? Well, we've actually talked about what the p-value is, so we can just kind of translate this into English. The probability of a sample mean of 90.45 or a less likely mean or a less likely. So that would be like, smaller than 90.45, or so that would just be the areas here, or a less likely mean, given, or let's just say assuming a mean of 94 is 8.72%. Okay, now, yeah, p-values are tricky, but if you understand what the p-value is, it actually becomes very easy to get these questions. And a lot of teachers, because it's a little bit more tricky, they'll kind of just, this is the formula, don't think about, this is kind of the formula, this is the process for getting the p-value. You don't need to understand how it works or why it works or what you're doing. But I think that it's really important to understand what it is that you're doing, understand the process of a question. And then it becomes really not that difficult.